We'll take another example. So the open loop transfer function of a unity feedback system is given by g of s is equal to k by s into s plus 1 into s plus 2. Find imaginary crossover point. First we'll calculate first we'll look at the possibilities. There are 3 poles available and there are no zeros. 3 poles, no zeros, and all my poles are left of the S-plane. Therefore, you cannot have the first possible, that means having poles in the left of the S-plane, having zeros in the right of the S-plane, or vice versa is not possible because we have only poles. Second is look at the asymptotes. So we have 3 poles are there and there are no zeros. Therefore, number of asymptotes are 3. When you have 3 asymptotes, you know the angles minus 60, minus 180, minus 300. So let us look at those poles. Here I have one pole, s is equal to 0, s is equal to minus 1, s is equal to minus 2. Then you can find out the centroid, you will get somewhere. But we want to look at the angles and their position which are going to the infinity. So one is towards 60 degrees. Let us say I have this centroid. From this centroid, so 60 degrees will be like this, and 180 degrees is negative real axis, 300 degrees is downward direction. Therefore, these 2 asymptotes are crossing the imaginary axis. When they are crossing the imaginary axis means certainly there will be imaginary crossover point. Let us see how to calculate it. Now the procedure is 1 place gh is equal to 0, and we will get it as s cube plus 3s square plus 2s plus k is equal to 0. Now if you form the Routh array, then 1, 3, 2, k. So the highest degrees you have s cube and this is s square. Then s power 1 will be, we can calculate this into this. That means you have 3 into 2, 6 minus k divided by 3, and the other one is 0, and the last element is you have a k here that can be carried forward to s power 0. Now what is the odd number? S power 1. We try to make this row 0. So if we try to make, that means this term will be equal to 0. So what is this term? 6 minus k divided by 3 is equal to 0. So you will have k value as 6. So when k is 6, so s power 1 row is having all 0 elements. That means there is a possibility of having imaginary crossover point. Now how to find that? So take the auxiliary equation, which means I have s square term coefficient, we have 3 and k. We can write the equation a of s is 3s square plus 6 is equal to 0. You can find out the root s is equal to plus or minus j root 2. So plus or minus j root 2 is nothing but your imaginary crossover point. So if you locate imaginary crossover point, you have the imaginary axis, plus j root 2 is here, minus j root 2 is here. So your root locus branch, while it is crossing the imaginary axis, it has passed through the particular point. So that is very crucial point in root locus. So it has to cross that point in bottom side and top side and also bottom side. So this way we can calculate imaginary crossover point. Now what is the indication of imaginary crossover point? So in any problem, if imaginary crossover point exists, means the closed loop system will be conditionally stable. Means, so for certain range of k values, system is stable, and the remaining range, the system will be unstable. So if it is crossing the imaginary axis, means it is going either from left of the S-plane to right of the S-plane. When the entire root locus in the left of the S-plane, then the system is stable. When the entire when the root locus shifting from the left of the S-plane to right of the S-plane, means system is going to be unstable. So certain range we have stable region and certain range of k we have unstable. So which is called conditionally stable system. Now if imaginary crossover point does not exist, if it is not there, not possibility, then what does it mean? The system may be either absolutely stable system, which means for all the values of k, my system is stable. Means you vary the k value from 0 to infinity, all my poles are lying in left of the S-plane, hence the entire root locus will be in the left of the S-plane only. Or the other possibility is system may be absolutely unstable system, which means For all the possibilities of k values, we cannot make the system stable. System, all the poles will be in the right half of the S-plane only. It is called absolutely unstable system. So therefore, two things here. If you have imaginary crossover point, system is conditionally stable. If there is no imaginary crossover point, either the system is absolutely stable or absolutely unstable. Next, so we have another important rule, that is angle of departure, angle of arrival. So what is this angle of departure and angle of arrival? First we will define angle of departure. It is the angle at which one of the root locus branches leaves the complex pole. So leaving is departure. So it is the angle at which one of the root locus branches leaves the complex pole. So this angle of departure can exist if at all you have complex poles. In any given problem, if there are no complex pole, there is no need to calculate angle of departure, right? Angle of departure exists only if there is a complex pole. Then how to calculate this angle of departure? Now the formula is angle of departure phi d is equal to 180 minus phi. What is this phi? I can define it as phi is equal to sigma phi p minus sigma phi z. What do you mean by sigma phi z? So sum of the angles of the vectors drawn to the complex pole to all other poles. Let us say I have one complex pole and there are three remaining poles at different locations. So you draw the vectors from the other poles to the complex pole and measure those angles, add them. That will be the phi p, right? Sigma p. So sigma p is the sum of the angles of the vectors drawn to the complex pole from all other poles. Then we can calculate generally phi p by drawing the vectors by measuring, or analytical also we can do it. Similarly sigma phi z. So sum of the angles vector drawn from complex pole to other zeros means, so you may have poles and zeros in the system. Therefore from complex pole to all other complex zeros you draw the vectors, and that will be, you add all the angles, sigma phi z. So phi is equal to sigma phi p minus sigma phi z, then the phi d is 180 minus phi. So this phi d is for a complex pole. There will be another complex pole which is a complex conjugative, that is phi d star is minus phi d.